what I've been seeing is that databases are kind of lindy. Like the longer something has been around, the more likely it's going to be useful in the future. And so I actually think, our bet at Timescale and what we're seeing from developers using these like old technologies, but combining them with stuff on the cutting edge is kind of how you build applications.
Welcome, Collective Nation, to another installment of the GenAI Collective podcast, Collective Intelligence. Today, we have the AI lead at Timescale. Do you mind just letting us know what is Timescale and your role there?
Fantastic, Thomas. Thanks so much for having me. My name is Avthar. I lead AI products at Timescale. We're a Postgres database company. So Timescale has been around for almost 10 years now, enabling developers to build applications using Postgres that are over and above the general relational database use cases. So one of the products has to do with time series and real-time analytics. And my product group is all about AI and vector data. And so we build products that enable developers to build AI systems like RAG and semantic search and even AI agents using Postgres as the core database that powers the retrieval and data functionalities. We've been building that for about 2 years now. And we have a number of our core product is called PGAI, and it's a complement to the very popular open source extension PG Vector, and all our work is open source. And so really excited to come on the pod and chat to you about what we're building and how we've been helping developers.
And so can you talk a little about your role there in particular? What types of problems are you running into and dealing with on a day-to-day basis?
Yeah, so my role, I think on paper, I'm the product lead or PM is probably another way to think about it. I think most of what I do is I spend a lot of time talking to developers that are building AI applications and listening to them about their problems and like what they're trying to do. And I think the biggest problem that I think about on a daily basis is how do you build an AI application that gives you reliable, accurate answers? And I think RAG is generally the solution to that. Some sort of retrieval augmentation is the solution to that. We've also been looking at problems around structured data retrieval, because I think most of the time you have data that's unstructured data. Maybe it's PDFs, maybe it's blog posts, stuff like that. But then you also have data that's structured in nature, whether it's sales data, transaction data, just like relational data in general. So I think the high level problem that my team solves is, hey, how can we enable developers to build useful applications with the minimal amount of headache using the tools that they already know and love? And so our product is all about extending Postgres for AI applications. And so most of my job involves talking to developers, both paying customers of Timescale as well as just free users in the community. As I mentioned, our work has a huge open source component to it. Both the extensions that we've released that actually basically turn Postgres into a high performance vector database are open source in nature. They're completely free to use. And so most of my days are spent talking to them, learning about their problems, understanding, what they're struggling with, and then working with my team of world-class engineers to figure out how can we actually help these folks make progress and build stuff that's going to make their life better.
Yeah, so let's just take a step back here and to describe the problem that Timescale is facing with. So maybe we can just go step by step between, people who are using a relational database and then what problems that they are facing to then going to a non-relational database, and sort of incrementally, what are the problems that they're facing and why are they coming to Timescale on that journey?
Yeah, it's a great question. The way I like to think about it is when ChatGPT came out back in 2022 or so, the thing that everyone saw when they began playing with it was, hey, I think this chat is really powerful, but what I wanted to do is work with my business data or my specialized data set or my private data set that is not available on the internet for underlying training data. And so this problem came about like, hey, how do you actually connect AI models like GPT-4o or like Claude Sonnet 3.5 and most recently like R1 from DeepSeek to these focus, maybe proprietary, sometimes private, sometimes just business data sources and reason on that data and build useful user-facing applications from there, or do some reasoning on that data. And the answer to that question became this category of databases called vector databases, where essentially what vector databases do is allow you to search over unstructured data, meaning things like text or PDFs, data that you don't traditionally store in relational tables. They're just like blobs of data. And what those databases do is they create vector representations of it, so that we can represent those in high-dimensional space and then essentially find patterns and connections between them. And this allows you to do the classic like chat with Paul Graham's blog posts, where you have a query that you put in, and then you look for, hey, from my corpus of data in my knowledge base, which are the blog posts that are most similar to this that I can then put over in my LLM context window, and then do some reasoning and answer a user question. So the problem really stems from this idea of, okay, it seems like you need to be able to handle vector search in order to create a good AI application and to create a good RAG application. But first of all, like, does this mean you need like a separate database? And this is where you get into a lot of the engineering concerns, where it's like part of it is AI engineering, but the other part is just the reality of building a good user-facing application. Like, you need a database, you need data infrastructure, and especially with a lot of AI applications, they're newer applications, they're smaller teams, or in companies, like if you look at companies adding AI capabilities to their applications, they want to move quickly. And so any friction around managing data infrastructure is going to slow them down. And so what we began hearing was, is there a way to get the benefits of vector search without having to use a separate vector database? Because what does mean for teams? It means you have to manage a whole separate system. It means you have to learn a whole new query language. It means you have to pay sometimes for a separate vector database. And it also means you have to synchronize data between this second system and your kind of core user database, or your core like business database that you kind of need anyway. And so those are all these problems with like using a separate vector database. And where we come in is we build around this open source extension called PG Vector that essentially says, hey, Postgres is a relational database. If you add this extension to it, which is essentially, it's a way to give Postgres this vector database capabilities without having to use a whole separate database. Like, you could just add them onto the Postgres you already use. And what we've done is say, hey, let's actually build some more complementary things around that. And so what we've built is an extension called PG Vector Scale, which extends PG Vector for scale and performance, and another extension called PG AI, which adds things like automated embedding management and synchronization to Postgres. And the reason why that's important is, one, it allows you to not have to use a separate vector database when you're building these applications. It means that you just have one source of concerns. You only need to learn one query language. Most engineers know SQL, and Postgres is the most loved database in the world. I think it was like the most popular for the past 2 years, according to the Stack Overflow developer survey. And where the tools that we've built come in, essentially allow you to do all these things that you need to build a production-grade RAG application. So going beyond just vector search and looking at things like, hey, search at scale, like what happens when you have, 50 million, 100 million, a billion embeddings, where you have like hundreds of documents. Maybe you're doing like a legal research use case or like a financial research use case, where, just chatting with 10 blog posts, it's a very different scale of data. And then also looking at things like filtered search, where you're dealing with things like, multi-tenant use cases where you need to cater for multiple users. Data type, but things like time-based filters, this is something we see a lot, where you don't just want to find things that are semantically similar, but you want to constrain the time window of relevance. And this is all part of what I call like getting an AI application that actually gives you accurate, useful answers, rather than just building a RAG system with semantic search. So that is a scope of problems that we deal with. And our philosophy is to say, okay, how can we enable developers to do this and achieve their goals while using the tools that they know and love, and avoid having to deal with extra complexity as they go about building an AI application? Because I think, like, on one hand, just learning how to prompt and learning how to actually do things like RAG pipelines is like very complex, and that takes a long time. Can you actually save developers this engineering and data complexity and data infrastructure complexity? That's kind of the problem that we solve, and that's where our suite of products come in, namely PG Vector Scale for scale and performance, and PG AI for automated embedding creation, and then complementing PG Vector, which gives that kind of foundational search and storage for vectors in Postgres.
So there's a spectrum of solutions you could choose from. So you could go full vector database, you could go full relational database. Who is the sweet spot customer persona for you where they want to sort of add on to their current capabilities?
That's a good question. It's something that I often talk about a lot, where in any product that you build, you can't really build for everyone. You're never going to serve everyone's requirements. And so the way I like to think about who we serve at Timescale and with our suite of products are folks who have really large scale RAG or agent applications. And so, for example, as I mentioned, a couple of domains you look at, for example, in the financial industry, where if you're doing research over, let's say, all the equities on the New York Stock Exchange, or if you're a hedge fund doing research on what's going on in markets around the world, et cetera, and if you think about a single PDF document that's like 100 pages, if you take that times all the stocks on the New York Stock Exchange, multiple research reports, that data is going to pile up quite a lot. And so for those kinds of use cases where scale and performance is a concern, and you're not just dealing with an employee handbook that you're chatting with, or 10 PDFs in a help center or something like that, that's kind of the sweet spot that we've been able to help customers. There's a customer that I can publicly talk about. They're called Market Reader, and basically what they do is give developers real-time updates on why the market is moving. And they have a RAG pipeline that essentially takes in news data, takes in stock market data, and correlates it with the real-time news stories that are coming in, and gives their users a summary. And all that takes place thanks to Postgres and Timescale and their RAG pipeline built in that. I think the other use case that's very interesting is where you're building RAG applications that are both multi-tenant as well as involved things that go beyond just vector similarity search, where I've mentioned things like filtered search. I've mentioned things like where you actually want to join on user data or business data. All of that actually has its home quite naturally in a relational database structure. Mm-hmm. And so, for example, let's say you have a table of vectors, but what you really want is you're building an application and you want to restrict the level of access. And maybe you have another table of user permission data. If you were to use a specialized vector database, you'd have to find a way of, joining that on the application level, and you'll have to find a way of making sure that, your permissions are up to date and the application level needs to take into account of that, etc. Whereas if you keep both of that in the same database, this is a simple join. And so these kinds of applications where you actually have to do filters and you actually want to join on your business data, that's super important. So for example, if you look at maybe legal applications, this falls into that. Or if you look at any kind of, I've mentioned this before, like if you're building like a user-facing SaaS, and like different users in your SaaS have obviously different permissions, they can view different files, etc. Or for example, if you're building like an internal company chatbot and the CEO has a certain level of data permissions, but the rank and file employee like me can't obviously see everything. How do you enforce that easily, and how do you kind of enable those capabilities in your app with the least amount of headache? So that's a couple of examples. I think if you look at the history of vector databases, they've come out of these kind of single purpose domains where if you look at like, I think it's pronounced FAISS or FASS, FAISS, Facebook AI similarity search. Yeah. That's just single purpose. Like, hey, all that matters is doing like recommendations and similarity search. There's really no joins on business data. There's no filtering, etc. And so I think our sweet spot is where you need kind of scale and performance, but you also have these other concerns around filters and joins that are necessitated in your application. We've seen a lot of successful customers, and I actually think those are the most common RAG applications that you see today. I think everyone starts off building, chat with your docs sort of things. But once you get kind of more complex, dealing with the kind of business requirements, quote unquote, become most of where the complexity is.
And so I guess an extension of that, you at Timescale have this idea of letting databases handle the complexity. And I think one of the things that developers don't want to do is sort of a database maintenance job where they have to make sure their database is up to date all the time. Like, can you just talk about how Timescale might have a differentiated approach to handling those issues?
Yeah, so I think I assume you're talking about, there's this whole concept of a managed database, which Timescale does offer, but, we also welcome folks self-hosting and things like that. I think one additional concept that I'll bring up is this idea of like pushing complexity to the database and letting the database handle things that you otherwise might have to do manually on the application layer. A good example of this is this feature that we built called Vectorizer. And it basically deals with this problem of, let's say you have a RAG application and you're adding documents or you're deleting documents. In the old paradigm of just using a specialized vector database, you'd have to go and run your embedding pipeline. You'd have to make sure that your database is up to date. But what if it was just like a database index where you do your adds and deletes in the database, and then the index just updates itself? And so that's why we built this Vectorizer feature that really takes away the complexity of embedding, creation, and updating, so that you can just use your application, you can add documents, you can delete documents, etc. And then we'll take care of like actually creating the embeddings. Those are created in the model of your choice, as well as doing the updates and deletes in your vector search index so that those are up to date. Some cool knock-on effects of this is that it actually makes it very easy to test and experiment with your with different embedding models. And this is something that, again, in this quest for getting accurate and getting useful AI answers, you want to make sure that you're testing and experimenting to understand, like, okay, what is your evaluations look like? What does your recall look like? And I think that especially now with like all the innovation going on in open source, a question I often hear from developers is like, hey, I started off using OpenAI like 6 months ago, but like, should I move to open source? Which open source models are good enough? And unfortunately, the question always is like, hey, it depends on your data set and it depends on like your requirements. But now with this kind of easy experimentation feature, you can just run that experiment really easy rather than having to build like a separate pipeline to embed your data with open source embeddings, etc. We've reduced it to just like a single SQL query. So that's a good example of that philosophy of like letting the database handle complexity where it can. And we also know that one thing I will point out is that we're not like database maximalists. I don't know if that's a term, but like that's like not us either, where we actually think that certain jobs that the database shouldn't do. For example, like we wouldn't do embedding creation inside the database. Like the way that Vectorizer works is that it works with where the database communicates with the third-party worker. And then that's where embeddings get created. And then those embeddings get sent to the database. And so we're mindful of those things like that, where, understanding at which layer of the stack the complexity needs to handle, and then also how to abstract all that away and create interfaces that users can actually use quite easily without having to worry about all the details.
Got it. And so I guess one key point here is, how do you think about onboarding, right? Like one of the biggest things to using AI in deployment is just getting the data in prepped. How are you thinking about how on hand you want to be with that versus sort of letting customers use the platform itself?
Yeah, I think this is where there's kind of a two-part solution where if you think about developers, like there's like kind of two classes of developers that you have to build for. One is the developer, and I always say that our biggest kind of user profile are experienced developers who know their way around the database, but they're now being tasked with building an AI application, whether it's from their boss, whether the company is now trying to reorg around AI. And so they're thrown into this world of AI engineering, and they kind of have to find their feet. And so for them, what we do is we allow them to get started quickly using the tools that they know and love. So for us, this means things like SQL interfaces for things. It means things like good defaults on things like chunking and splitting and stuff like that. But then after they kind of get comfortable, you want control. You don't just want to have a black box where you're like, oh my gosh, I'm so frustrated. I can't change this parameter. I can't change this like splitting mechanism or something like that. This is some of the frustrations that people sometimes talk about with various like AI application frameworks. LangChain is the most popular. They actually probably get more hate than they deserve, to be honest. But this is something you hear from those users as well. And so what we try to do is give developers ways so that they can actually see what's going on under the hood if they want to, and turn those knobs and dials. And so everything is super transparent, but that is complemented with things like smart defaults and making it very easy to get started. So it's kind of like those two concerns is what we try to balance.
Okay. And so then what is the sort of killer use case here? So we talked about problem set. We talked about sort of let's on-ramp onto Timescale. I guess another key piece is now that I'm using Timescale, where can I start identifying use cases immediately in my organization to kind of test it out and work with it?
Yeah, I think this is actually something we're still learning about new use cases every day, because I think AI and LLMs is such a universally applicable technology that the limitations on use cases is basically the limit of your imagination in an organization and what your appetite for risk looks like. And so I think that, for us, we've seen a slew of internal focused applications where, for example, part of Timescale's core demographic for the time series product that we have are these IoT companies and energy companies. These are they're not like traditional tech companies, but they have large groups of engineers working on things like smart machines and manufacturing devices, etc. And as part of that, they have these field technicians that need to go and repair these machines or check on them, etc. And so one common use case that we're seeing is these like internal support co-pilots where what they actually do is enable these field technicians or support folks to quickly get information about, specific models of machine or specific, news about like, this model got a software update or something like that, find that information quickly. And so I would class that as like internal co-pilots is a huge kind of use case or application type that we're seeing quite a lot. The other one I think is folks, and this is where it like gets to some of the work that we're doing, and some of it is still very early. Like we have some previews on our GitHub repo, but it's not officially announced. But since this is a podcast for the people, I'll go into some of the interesting details. Is where you actually want to go beyond unstructured data, where there's only unstructured data can only get you so far, and you actually want to marry that with insights from structured data. And I already alluded to this, where we talked about the power of filtering and we talked about the power of like joins with your business data. But we're seeing, for example, now with like agents coming up, that ability for an agent to be able to like query a knowledge base, but also query like a regular database table, or to query like a table of like transactions and sales. Like a good example is like if you think about an ideal Amazon chatbot, they'll be able to both give you product information, or this applies to any e-commerce example, for example, product information, but also information about your account and your orders and things like that. And so that involves this marriage of structured and unstructured data. This is something that we're actively investigating, and I think this is going to be a trend as we see like these more powerful applications. And again, this comes down to the theme that I talked about in the beginning around you want to build AI systems and AI applications that give you the most accurate and useful answers. And I think what we're seeing is that we started off as just like vector search as being like the solution, but now we're seeing we need more complex building blocks for data. And that's where, some other approaches have come up, things like GraphRag and, things like that, which is really good. And those work in a lot of cases. And I think what we're focused on is these these other use cases that involve this marriage of both vectors, vector search and structured data querying as well. And the third example, just to close off this segment, is we're seeing a lot of interesting like integrating RAG into user-facing applications. And I think that one of the cool things about these sorts of products is that it allows you to kind of field any kinds of questions from your users. So for example, as I mentioned earlier, one of our marquee customers is a company called Market Reader, and they make this financial insights platform. And so their users come on and they're like, okay, what's going on in the market? Why is NVIDIA down so much today? And then they get the news that like, oh, NVIDIA is down because DeepSeek got released and everyone is freaking out, or whatever the news might be on that day. And so these are the sorts of things where you think about like wherever you have, once again, this marriage of unstructured data that you want to search over, but also relating it to relational data, like, for example, stocks or some sort of equities report, or anything, for example, laws that take place. We work with a customer, I can't name the name, but they are doing a big project around laws in the EU. And we all know that the EU loves regulation. And so those are always kind of evolving areas, and it involves a large amount of data that needs to be indexed and being ready for search and things like that. So that's a overview of some of the use cases. And I think we're going to see, part of my personal belief is that as these models get better, new use cases are just going to be unlocked, because either today it's too expensive or it takes too long. And, we're seeing with things like O3 Money and DeepSeek most recently, that the model, like the cost per tokens are going down, the reasoning power is going up. And so I expect to see like a whole new set of applications beyond just the, chatbot sort of things emerge in the next kind of year or two, thanks to these more powerful, more intelligent models.
Okay, so that is a great segment actually to segue into kind of our final topic, which is this idea of what balance is there between putting reasoning into the model versus the database. For example, there was so techniques like determining how similar embeddings are to each other to determine sort of relation of meaning. Now we are having models that sort of nicely integrate reasoning into the model itself. And so I think it's a balance of long-term memory versus short-term memory. How much, how are we going to see this play out moving forward? And how much of that reasoning is going to sit in the database versus being done at test time?
Yeah, I think this is, it's a very interesting question, because I think there's a few different ways it could shake down. I think what we're going to end up having is these systems that are controlled by, the best reasoning models, something like a O1 Pro or a DeepSeek R1 or something like that, or maybe Claude 4 when Anthropic released that. And I think what's going to happen is that you're going to see these reasoning models leverage tools that are really centered around the database. So, for example, I think about I was drawing this agent architecture the other day, and there's actually quite a few areas where like agents need a database. So, for example, as I mentioned, the classic use case is just having a knowledge base of data where you're like, hey, I have all these documents, I have these PDFs that is relevant for you. Agent, go and do your job, and come and ask me if you need something. Then you also have this other case of querying structured data, querying structured tables, things like that. You also have this other use case where you might want to store chats that the agent like has between the users that can naturally go in a database, facts, runs, traces, things like that. So there's all these places. I think what we're going to see is that I think one of the big questions is like, do you still need a database? Because like, what if you have infinite context? Like, can you just dump files, etc. in there? And it remains to be seen whether like the context length growing and the reasoning staying high quality is gonna kind of hold. I think there's this famous like needle in the haystack problem where as these context windows get much larger, LLMs tend to get confused and aren't able to kind of pinpoint what are the most important information. And so I think for me, like what I always think about is like, can you actually provide the LLM the most high quality context to give the best answers? And I think, for example, most recently, we're seeing this with OpenAI Deep Research where, and I'm kind of using this product every day since it got released. And one of the things you notice is that it's limited by the quality of the sources that it references. And so Deep Research has an amazing reasoning capability. It can write really good reports. It can check its answers. It can do comparisons. But if it's reading, if it's getting information from Bing about these like nonsense articles that like aren't very high quality, then you have a classic like garbage in, garbage out situation. And so I think that the way that databases play a role is less about keeping the intelligence in there, but more about making it easy for these agents and these LLMs to get high quality context, whether that's unstructured data, whether it's structured data, whether it's a combination of the both. This is where filtering, this is where these kind of complex, composite queries come in. I think that's kind of the future. It remains to be seen like how that shakes out. But I think what we're trying to do at Timescale is build ways that, developers can build products to give their LLMs the best context and at the end of the day, like do the most useful stuff for their users. So that's kind of how I think about it. It remains to be seen if, that's how it's actually going to shake out.
Yes, I totally agree. I think the key outstanding question is the context window, and some things that are being done is sort of the development of sort of recurrent neural networks that are being brought back to deal with this. But I think we have to, that's really the thing that we'll have to keep track of in terms of the impact on the database market as well, because the database market has just been, just for 40 years now, since the 1980s with Oracle. It's just been an incredible industry with all of these proliferation of use cases and databases, and I think LLMs just make the demand for that exponentially greater. So yes, remains to be seen, but I appreciate you sort of widening the scope and sort of taking it, making it a point upon the greater industry. And so with that, thank you so much for joining. Thank you so much for teaching us about Timescale and kind of what you're working on, and I appreciate you taking the time.
Thank you so much, Thomas. I'll say one more thing very quickly. I love this concept from Nassim Taleb, this concept of Lindy, which is basically like, hey, if something has been around for a long time, you can kind of reasonably predict for it to be around for a long time. And I actually think, like, for me, what I've been seeing is that databases are kind of Lindy. Like, the longer something has been around, the more likely it's going to be useful in the future. And so I actually think, our better Timescale and what we're seeing from developers using these like old technologies, but combining them with stuff on the cutting edge is kind of how you build applications, because then you get the stability of the stuff that's really old. You figured out all the ways that it can break. That gives you its solid foundation. And then you combine that with things on the cutting edge, which is your frontier models, your reasoning models, those kinds of things, your agentic architectures. And so, yeah, I think that's kind of, how I see it playing out. And thank you so much again for having me. This has been a lot of fun.
Awesome. Thank you.